southern Italy, a city under threat. Naples, flanked by two dangerous volcanoes. On one side, Vesuvius, destroyer of ancient Pompeii.
None of them met with a peaceful death. They were afraid, they were panicked, and it was terrifying.
And on the other, Campi Flegrei, an invisible monster that threatens 3 million people.
This is the most dangerous volcano in the world.
Now, scientists are seeing increases in volcanic activity and are scrambling to unlock the inner secrets of these volcanoes before it's too late.
There's no choice. You just have to go to a place which is relatively difficult to get to.
Can they find ways to predict the next eruption?
This is evidence of how fast things change in this area.
Can they save this jewel of Italy from another disaster?
This volcano can erupt at any time, even tomorrow.
Could Naples become the next Pompeii? Right now on Nova.
As an American-based supplier to the construction industry, Carlisle is committed to developing a diverse workplace that supports our employees' advancement into the next generation of leaders, from the manufacturing floor to the front office. Learn more at carlisle.com.
More than 1,000 volcanoes around the world are active. Driven by Earth's fiery interior, they can erupt at any time, blasting molten rock and ash into the sky with frightening power and speed. And unleashing deadly destruction on those who live in their shadow. Volcanoes have the power to kill thousands in the blink of an eye. A stark warning for the people who live here, in the beautiful port city of Naples in southern Italy. This ancient and vibrant metropolis of over 3 million people might seem an ideal place to call home. But looks can be deceiving. It's built right next to not one, but 2 active volcanoes. Each has a history of catastrophic eruptions. To the east is the well-known Vesuvius, a classic cone-shaped volcano that has claimed thousands of lives, erupting as recently as 1944. And to the west is an almost unknown volcano, Campi Flegrei, hidden below ground in an area where hundreds of thousands live. It doesn't even look like a volcano. And yet, it has the potential to be far more destructive than its more famous neighbor. Today, there are ominous signs that both volcanoes are still active. Swirling clouds of gas and bubbling pools of mud. What do these mean about the likelihood of a major eruption? It's hard to imagine the impact on such a densely populated city. And yet, it's happened before. Just 15 miles from central Naples is the site of one of history's most infamous volcanic disasters. The Roman city of Pompeii. In year 79 of the Common Era, Vesuvius exploded and buried the entire city in over a dozen feet of ash. Over the last 150 years, archaeologists have been carefully uncovering the remains, revealing a scene of carnage and death. A city and its people frozen in time at the exact moment an eruption struck. Among these ruins are crucial lessons about how a volcanic disaster can unfold, and evidence of just how suddenly an eruption can strike. For archaeologist Kevin Dykes, this human tragedy is a stark warning from history.
Walking around the ruins today, it's really easy to forget that this was actually a functioning Roman town 2,000 years ago. Within the city walls, perhaps 15,000 people of different classes, different ethnic makeup, all trying to survive in this city.
Remarkably, everyday items like food survived the eruption.
Che cose sono?
Walnuts, walnut kernels, already peeled.
One of these food items shows how the people of Pompeii were caught completely off guard when Vesuvius erupted.
Allora,
This one is one of the 81 breads found inside an oven that was fully operational at the moment of the eruption. With one peculiarity, there is still the fingerprint from the baker's thumb.
oh my gosh. This really brings a human element to this, right? Bread being baked at the time of the eruption, and the baker. Hopefully the baker escaped. Hopefully he lived the rest of his days baking bread somewhere else, but we have no idea. But it really tells us something about the eruption, how unexpected it was.
In the face of this sudden cataclysm, many of Pompeii's residents fled in blind panic. But some chose to stay behind and shelter in the city. They paid the ultimate price. Their last desperate moments preserved for eternity as Pompeii's most evocative remains.
These are but a few of the approximately 2,000 victims that decided to wait out the eruption and, of course, didn't make it. Now, what we have here are not the bodies themselves, but these are the exact poses of the victims at the very last moments of their lives. After their death, they were covered with ash. Over time, the soft tissue decayed, liquefied, and leaked through the ash, leaving behind these voids. Archaeologists pour in the plaster of Paris, leave them to dry, and we get these exact poses. And this is a really macabre reminder of what can happen in the blink of an eye to an entire city.
Could Vesuvius erupt today with such violence? Do millions of people risk the same fate as their ancestors? Centuries have passed, but one thing hasn't changed. Vesuvius is still active. Driven by a geological collision that has been shaping this part of Italy for millions of years. To the east of Naples, two of the planet's vast tectonic plates are crashing into each other. The African plate is being forced downwards in a process called subduction. As it descends toward the hot center of the Earth, it gets warmer. This causes rocks to melt and turn into liquid magma, which rises towards the surface. To the east of Naples, there are weaknesses in the rock. Here, the magma can break through. And if it has enough power, it can even trigger an eruption. It's this constant subduction which keeps Vesuvius active and fuels its eruptions. Due to this ever-present danger, the volcano is kept under 24-hour surveillance. At the Osservatorio Vesuviano, scientists are watching for the warning signs of an imminent eruption.
We have 1,500,000 people that are at high risk in case of eruption.
From a high-tech control center, Francesca and her colleagues pick up seismic activity, movements in the Earth's crust.
In these screens, we see all the signals that came from the sensors that we have installed on Vesuvius.
In all, there are 150 sensors on the volcano, all listening for earthquakes. These can indicate if an eruption is on the way. Each eruption begins when magma starts to rise upwards from deep in the earth. It pushes through weaknesses in the rocks towards the surface. If its way is blocked, it builds up more and more pressure until it fractures the rocks apart. This is so violent, it generates earthquakes which the scientists can detect at the surface. Every time the magma breaks through the rock, it generates a new quake, until the magma erupts out of the volcano. Francesca and her colleagues detect minor earthquakes nearly every week. And this constant monitoring is vital. Vesuvius can change very quickly.
We have active volcano, and of course, if a volcano is active, for sure it will erupt again. We don't know when.
Mindful of Vesuvius's lethal past, the observatory's scientists don't rely solely on earthquake monitoring. They have another, more hands-on way to monitor the magma. At the summit of Mount Vesuvius is a vast crater, nearly 1,000 feet deep. Every month, a monitoring team carefully descends into this gaping hole to gather data. Today, geologist Chris Jackson is joining them.
Some of the critical bits of data about the volcano's behavior and the kind of threat it can pose, it can only be gotten from one particular location, so there's no choice about trying to collect it somewhere easy. You just have to go to a place which is relatively difficult to get to.
Their mission is to collect vital gas samples. These could hold clues about how close the magma is to the surface. To get them, they need to climb down into the heart of Vesuvius's massive crater. Their target is a fumarole, a gap in the rock where gases from the magma escape. The team takes samples to measure the levels of one of these gases, carbon dioxide.
What we're really interested in here are spikes in carbon dioxide coming out of the volcano, because that spike in carbon dioxide might mean that there's new magma coming into the volcano, which could occur immediately before it erupts.
Rising magma experiences less and less pressure, causing it to release more and more carbon dioxide.
The magma within a volcano is a little like the soda within this soda bottle. Both of them contain carbon dioxide, so CO2 dissolved within them.
As the pressure drops, the gas comes out of solution, forming bubbles which can escape to the surface.
The reasons the bubbles came out of the soda is because we released the pressure. And the same happens when magma rises up within a volcano. It is that decrease in pressure that allows the gas bubbles to expand and to eventually come out the top of the volcano.
Constant monitoring of carbon dioxide and earthquakes is vital to predicting when Vesuvius might erupt again. But this isn't enough to keep the people of Naples safe. For that, scientists also need to understand the consequences of an eruption. Who would be most at risk? And what dangers would they face? Clues can be uncovered by analyzing past eruptions, even if they happened 2,000 years ago, such as the annihilation of Pompeii. Remarkably, there was a witness, the Roman author, Pliny the Younger.
This is the very first eyewitness account of a major volcanic eruption. On August 24th, in the early afternoon, my mother drew my uncle's attention to a cloud of unusual size and appearance. Its general appearance can be best expressed as being like a pine tree. We don't think of a pine tree as an analogy for the cloud of a volcanic eruption. But if you come to Italy, if you come to Campania and see the type of pine tree that grows here, you realize that what Pliny was describing is a perfect analogy.
In modern times, scientists have seen this same distinctive pine tree-shaped cloud again and again. Called Plinian eruptions, these are the most explosive and the most lethal. But how exactly did a Plinian eruption kill around 2,000 people in Pompeii? Volcanologist Claudio Scarpati looks to the ash left behind for clues.
In this deposit, we see different layers, coarse layers, fine layers. These different layers are different phases of the eruption.
The bottom layer was deposited in the first phase of the eruption. It consists of pumice, small pieces of white volcanic rock. Amazingly, their size can be used to calculate how high the eruption reached, an indication of its power.
The size of the particles is proportional to the height of the column. Taking these fragments all around the volcano, volcanologists were able to define the height of the 79 AD eruption column as 32 kilometers high. The Roman people saw a column that was 32 times the height of Vesuvius.
This was a massive eruption. Gas and pumice exploded out at a rate of over 1.5 million tons every second, forming the distinctive pine tree-shaped cloud of a Plinian eruption. This reached 21 miles high and was so vast it blocked out the sun. Then it rained pumice down on Pompeii and its inhabitants for 18 hours solid. Surprisingly, this sustained bombardment actually gave people an opportunity to escape. Pumice is such a light rock, it didn't present much of a threat to those who decided to flee.
This fragment could hit you, but without any problem. We know from Pliny that if you just put a pillow on your head, you can survive this first phase of the eruption.
But strangely, hundreds of bodies have been excavated from this layer of pumice fallout, meaning they died during this first phase of the eruption. What killed them? One clue is the location of the bodies. Most were found inside buildings. They had probably decided to shelter in their homes rather than flee. Many seem to have died from traumatic fractures to their skulls. Claudio thinks these deadly blows to the head are explained by the long duration of sustained fallout. 18 agonizing hours.
These roofs were quite flat, and so pumice accumulated, and the overload was too high, and so the roof just collapses. If you stay inside the house and the roof collapses on your head, you are probably killed.
Killed and then buried. A warning for today. 2,000 years later, Neapolitans still live in flat-roofed houses.
We see that the roof of the buildings of the towns around Vesuvius are still flat. So you could have the same effect, an overloading of the modern roof, and so in 2-3 hours, this roof could collapse.
The tragedy of Pompeii warns of the dangers of pumice fallout. But out of the 2,000 dead, only about a third died during this phase of the eruption. So, what killed the rest of the victims? Once again, the answers are in the layers of volcanic ash Vesuvius left behind. There is a sudden change from a coarse layer of pumice to a band of fine material, just over 1 inch thick. This smooth layer is characteristic of the dramatic next phase of a Plinian eruption. A ground-hugging volcanic surge called a pyroclastic flow. This is the deadliest outpouring a volcano can unleash. It is an avalanche of gas and rock, moving at up to 300 miles per hour. So why did Vesuvius suddenly start to produce a pyroclastic flow? In a Plinian eruption, the mass of material in the column grows and grows. But there comes a point where there is so much rock and debris that the eruption can no longer support all this weight. The column collapses back towards Earth, creating an avalanche of debris, the pyroclastic flow.
The column collapsed, and the gases and the solids and everything moved down like an avalanche.
In Pompeii, The pyroclastic flow crashed through the buildings and inundated people sheltering inside in a dense blanket of gas and fine ash. This is what claimed most victims in Pompeii.
Can you imagine the air being replaced by an impossibly large cloud of ash and gas and trying so hard to fight from breathing this in? Here we have, for example, this individual, and how clearly you can see his right hand pressed against his mouth. He no doubt had a cloth of some sort, trying to keep the ash from going into his lungs, and of course, it did not work. That ash meets your moist lung walls and clings to it like plaster on this wall here, and that's the last breath.
But the shape of some of the casts suggests the pyroclastic flow killed in an even more gruesome way.
This cast in particular is fascinating to me, and what's so interesting about it is the pose. You can see this individual died on his or her back, but the arms are up, the legs are up. Why is this? This is known as the cadaveric spasm, and it usually occurs in atmospheres of intense heat.
Pyroclastic flows can reach temperatures of hundreds of degrees Fahrenheit. This is what caused the victims to contort into these strange shapes.
So when this pyroclastic flow surged over the city, it caused the muscles to contract and turn inwards. You can see it in many, many of these casts. A lot of these individuals display this cadaveric spasm.
These people died instantly. The intense heat froze them at the exact moment the pyroclastic flow hit. What happened to Pompeii and its people is a stark reminder of the destructive power of volcanoes. And it could happen again. This is the reason that scientists have to keep monitoring Vesuvius's activity. But there is a far greater threat to Naples. Vesuvius isn't the biggest or most powerful volcano in town. On the other side of the city, scientists have seen an alarming increase in volcanic activity. Pisciarelli, a vast fumarole, a vent of bubbling gas and mud. In recent years, it has grown larger and turned into a destroyer. A few hundred feet away, expert in volcanic risk Antonio Costa is visiting a deserted building. Inside, the walls and floors are covered in a thick layer of solidified ooze. And the air is filled with the acrid smell of sulfur.
This building up to 10-15 years ago was like a sort of a club. There was a swimming pool there, there was a bar. People were pushed to abandon this place because it's not anymore habitable.
The volcanic vent has claimed the entire building. This hostile takeover began when gas from the vent punched holes through the floor and walls.
Here you can even feel, if you put the hand here, it's terribly hot.
As the gas cools, it releases dissolved minerals. These stick together to form the thick volcanic scum, which is now consuming the entire house.
This is clearly evidence of how fast things change in this area.
So where is the volcano that is driving all this activity? The vent is in an area called Campi Flegrei, which is home to hundreds of thousands of people. At first glance, it's hard to spot the volcano, unless you have a trained eye.
So when we think of volcanoes, we think of that, Vesuvius, the perfect conical shape with that beautiful crater on top. But at Campi Flegrei here, there's also some evidence that this is a volcano, but it's just far more subtle. Good? Yeah.
To take a better look at the lay of the land, Chris needs to take to the air. A monitor connected to a drone provides him with a bird's eye view of Campi Flegrei.
So the first thing you notice from up in the air is, as we come round to the shoreline towards the Bay of Naples, we start to pick up a prominent ridge line that comes all the way round towards the main city centre. It's clearly curved. And then within there, it's a very densely populated flat area here. This ridge line could be telling us something about a feature that is actually forming this landscape, an ancient, very large volcano. And in particular, we're actually looking at a caldera.
A caldera is a collapsed volcano. In the past, Campi Flegrei was a flat plain. Deep beneath was a huge reservoir of bubbling magma. Then the magma started moving upwards, smashing through weaknesses in the rock and erupting powerfully. But this left an empty void beneath the surface. With nothing left to support the weight of the plane, it collapsed downwards, forming a crater known as a caldera. Radioactive dating of rocks reveals that Campi Flegrei's caldera formed 15,000 years ago. And at nearly 8 miles wide, it must have been created by an incredibly large and powerful eruption. Volcanologist Giuseppe Mastrolorenzo thinks this sounds a warning for modern-day Naples.
It is very important to study the past eruption in order to imagine scenarios for the next eruption. Because in geology, what happened in the past will happen also in the future.
The remains of the eruption that formed Campi Flegrei's caldera can be found beneath the streets of downtown Naples. Here, there is a labyrinth of narrow passageways. These were hand-cut thousands of years ago to provide building materials for Naples. Today, they are a treasure trove of information about the eruption.
This is the Neapolitan Yellow Tuff Formation. Here, underground Naples, we have several tens of meters of this formation.
This rock has a powdery consistency, which points to the most deadly event in an eruption.
Here you can see a fine matrix of fine particles of ash. This is typical of pyroclastic flows.
In Pompeii, the pyroclastic flow, which killed more than 1,000 people, left behind a layer of ash just over 1 inch thick. But here, beneath the very center of Naples, the thickness of the pyroclastic flow reaches over 300 feet.
This eruption is about 10 times bigger than the Pompeii 79 AD eruption. If another eruption like this will occur in the future, all the people and buildings of Naples will be buried under hundreds of meters of hot ash. So nothing can resist this eruption.
In Campi Flegrei, there are hundreds of thousands of people living directly on top of an active volcano. If it erupts, deadly ash fallout and pyroclastic flows could even hit downtown Naples. With so many lives at stake, the pressure is on to determine when this volcano may erupt next. So scientists are keeping an eye on Pozzuoli, the biggest town inside Campi Flegrei's caldera. This is the site of an ancient Roman marketplace. Remarkably, these ruins could point to a way of predicting the next eruption. Within the remains is evidence of dramatic ground movements.
The clues we're looking for, we can see here on the 3 marble columns. And you'll notice that after about 10 to 20 feet above their bases, all 3 columns are full of small holes. These were holes produced by clams. They like to burrow into the marble to form colonies.
The clams that made these holes can't survive on dry land. They live solely under the sea. So at some point, these columns must have been underwater.
Now, we know from studies across the Mediterranean that the sea level has only changed at most by a few feet since Roman times.
If the sea level hasn't changed, there is only one other possibility. It must be the land that has risen and fallen.
This whole area must have sunk into the sea and then come back up again at least once since Roman times.
In fact, the ground in the caldera has a history of rising and falling. And eruptions are known to follow periods of intense uplift. Eyewitness accounts describe that in 1538, the ground rose rapidly. 2 days later, a minor eruption created this crater, called Monte Nuovo, on the outskirts of Pozzuoli. In 1982, the ground around the town began to rise again very quickly. This prompted fears of an imminent eruption. Tiziana Vanorio lived on the outskirts of Pozzuoli during this period and remembers the chaos it caused.
The first thing that became unusable was the harbor. Because of the uplift, the ocean floor became so shallow so that the ferry could not dock.
Over the next 2 years, the ground lifted up nearly 6 feet. Then, the earthquakes started.
On April 1st, 1984, more than 500 shocks overnight struck the town of Pozzuoli.
Fearing the worst, the authorities stepped in.
As the seismic activity kept increasing in the area, the town of Pozzuoli was evacuated. People had to flee their hometown because of the fear of an impending eruption. Pozzuoli overnight became a ghost town.
But strangely, the eruption never came. 2 years later, people were allowed to return to their homes. But a big question remained. Why hadn't Campi Flegrei erupted? Today, Tiziana is a rock physicist. And she's trying to answer this very question.
Hi, guys.
Okay. One thing piqued always my curiosity. Why a place can withstand such large and sustained deformation? So we had to understand why the rocks of the caldera behave this way.
1 mile below the surface of Campi Flegrei's caldera is a layer of hard stone known as cap rock. Could this rock contain an explanation for why the ground rose and fell so much without an eruption happening?
We want to understand how this rock would behave in the caldera under the conditions of temperature and pressure they experience in the caldera.
A specialized chamber mimics these conditions and also subjects the samples to extreme stress. What she finds is that the rock doesn't snap or fail instantly. It actually bends.
What we can see is that the cap rock is capable of withstanding high level of stresses, but also it shows from this bell shape a ductile behavior, which means this rock is not brittle.
This finding may explain what happened in Pozzuoli in the 1980s. Magma started moving towards the surface, where it heated fluids trapped in the ground above. These expanded, pushing up the cap rock. As it was ductile, it was flexible and bent upwards. This put stress on the cap rock, which began to fracture, generating the earthquakes. But it didn't crack completely. It could still resist the uplift and prevent an eruption. Tiziana wondered why the cap rock had such unusual strength. Looking under a high-powered microscope, she was surprised to find something you don't normally see in stone. The rock had formed a network of fibers that were knitted together.
The presence of fibers was really an intriguing discovery because the fibers are intertwined or braided together like the strands in a rope.
Tiziana thinks these rope-like fibers are the secret of the cap rock's strength, because she also sees them in a man-made material famous for its durability and toughness.
The same fibers that you can see here come from Roman concrete.
The strength of Roman concrete is one reason so many of their structures survive to this day. Tougher and more durable than modern-day concrete, it was the Romans' go-to construction material. And the secret ingredient in Roman concrete? Volcanic ash, called pozzolana, mined in Campi Flegrei. The Romans combined this with other ingredients to form their concrete. Remarkably, it seems a similar chemical process takes place a mile below in the volcano, under Pozzuoli. The cap rock is a natural version of Roman concrete. Its strength may have prevented Campi Flegrei from erupting in the 1980s. But this strength is also a liability. To fracture the cap rock completely would require colossal force. And that would result in an incredibly powerful eruption.
Having a cap rock that has high strength and ductility can be a blessing and a curse in a caldera.
Today, Campi Flegrei's cap rock is once more under stress. Since 2005, the ground has been rising out of the sea. And scientists think that the protective cap rock is being weakened. At Pisciarelli, there is a shift in the gases bubbling up from Campi Flegrei's magma.
The first gas that is released is carbon dioxide. When most of the carbon dioxide is escaped, the magma starts to release increasing amount of water, of steam.
Steam is the Achilles heel of the all-important caprock. Because when steam condenses to water, it releases large amounts of heat, which starts to fracture the rocks.
The rocks that cover the magma become weaker, and so could favor an eruption.
A catastrophe in the making for Naples and the 3 million residents threatened by an eruption of Campi Flegrei. Faced with this prospect, the observatory has enhanced its early warning system, installing additional sensors across the caldera.
We have sensors to measure ground deformations, to measure anomalies in gravity, to measure the geochemical activity, the temperature of the fumaroles, and so on. If there are big anomalies, you have more probability that an eruption is approaching.
And the scientists are about to add an ingenious new detector to their early warning system. This will offer Naples a unique form of protection. It's the brainchild of Luca de Siena. To see how the volcano is changing deep underground, he uses sound waves.
You could use dynamite or any sort of explosion to produce the wave, but that's obviously impossible in a metropolitan area of 1.5 million people.
Instead, Luca found a surprising and less disruptive source of sound waves, one that's already in place and operating 24/7.
It was quite astonishing when we discovered that we could use just the noise that the sea is producing at all time to see inside the volcano.
As the sea crashes into the shore, it produces a sound wave. That in turn propagates through the ground. By measuring the velocity of the wave, Luca can tell the kind of material it is encountering. If it's traveling quickly, it's passing through solid rock. But if it slows down, it's likely to be passing through fluids, like magma. Measuring the velocity of different waves crossing the caldera, Luca has built up a 3D picture of what lurks beneath Campi Flegrei.
We gathered 3 years of data, and what we got is this map, where we have found a sort of circular area, which is low velocity. Low velocity means that likely there are hot fluids inside this area. This could be magma.
For the first time, scientists can see where the hot fluids are across the entire caldera.
We know that most of the fluid come just under our feet, actually, here under the port in Pozzuoli.
But to know if an eruption is on the way, Luca needs to be able to see if magma and hot fluids are rising towards the surface. For that level of detail, he will have to expand the network. When it's up and running, Naples will be the first city in the world able to track these movements in real time.
If we measure this parameter all across the caldera, and we see that this parameter is changing over here, that's a marker that a possible eruption may happen.
This cutting-edge early warning system could be the best way of protecting Naples. It could buy people vital time to escape. An unexpected Plinian eruption of Campi Flegrei would put millions of lives at risk. In this nightmare scenario, the eruption could generate a huge cloud reaching tens of miles into the sky, pelting the Bay of Naples with pumice. Then, when the column collapses, A massive pyroclastic flow, heated to hundreds of degrees Fahrenheit, would tear across the caldera at hundreds of miles an hour, killing everyone in its path and burying Naples in an avalanche of ash.
All this area will be devastating, and 3 million of people will be killed by the pyroclastic flows.
The people of the Bay of Naples could suffer the same fate as the people of Pompeii, unless they remember one of the key lessons of this ancient tragedy. Those who hunker down during an eruption are the ones most likely to die.
If you have a strong eruption, the only way to save the people is evacuation.
We need to evacuate because it's the only way we can prevent a disaster, because there is no way you can save people from a pyroclastic flows.
If evacuation is the only option, this will take time and planning. In Naples, millions of people are crammed into a city of narrow and crowded streets, making advanced warning essential. One day, there will be another volcanic eruption, perhaps even more powerful than the one that wiped out Pompeii. But as scientists improve their prediction and early warning systems, the next time there will be a crucial difference. They'll know an eruption is on the way ahead of time, allowing millions of people to escape with their lives.